Welcome to Unit 14 on vector spaces. We'll explore three fundamental concepts: subspaces, linear independence, and basis and dimension. A subspace is a subset of a vector space that is itself a vector space. Let's visualize this in three-dimensional space, our crew. Examples of subspaces include any line through the origin, which is a one-dimensional subspace, and any plane through the origin, which is a two-dimensional subspace. A line that does not pass through the origin is not a subspace because every subspace must contain the zero vector, which is at the origin. To verify a subset is a subspace, check three conditions. It must contain the zero vector, be closed under vector addition, and be closed under scalar multiplication. Vectors are linearly independent if the only way to combine them to get the zero vector is to use all zero coefficients. This means no vector can be expressed as a combination of the others. These two vectors are linearly dependent because v2 equals 2 times v1. When one vector is a scalar multiple of another, they are dependent. These two vectors are linearly independent because neither is a scalar multiple of the other. Together, they span the entire two-dimensional plane. To test if vectors are independent, we solve for coefficients that make their linear combination equal 0. If only the trivial solution exists, the vectors are independent. A basis is a set of vectors that both spans the vector space and is linearly independent. This means every vector can be uniquely expressed as a combination of basis vectors. The standard basis for R squared consists of E1 equals 1, 0 and E2 equals 0, 1. Any vector in R squared can be written as a unique combination of these basis vectors. There are infinitely many possible bases for the same vector space. As long as vectors span the space and are linearly independent, they form a valid basis. The dimension of a vector space is the number of vectors in any basis. For example, R squared has dimension 2, R has dimension 3, and all bases for the same space must have the same number of vectors. These concepts build on each other. Subspaces are special subsets, linear independence eliminates redundancy, a basis combines spanning and independence, and dimension counts the basis vectors. Together, they form the foundation of vector space theory.